I'm going to work through this problem. This is number 5 on the 2D conservation of momentum. First off, before you start trying to throw arrows at it, you're going to have to go back and read the problem and see what's going on. So it looks like we have an elastic collision, and so to write that out, just the basic equation would be you have PI of the bus, okay, plus 0 because vulcanized rubber man doesn't have any momentum to begin with. Then at the end you have the momentum of the final momentum of the bus plus the final momentum of vulcanized rubber man. So over here in my equation, this is my working equation, this right here, my working equation. That's what I'll use to figure out which arrows I want to put where. This would be, what I'm trying to ultimately find is what is the final momentum of the bus. So, do some black here. So, P final of the bus, sorry, I messed that up. Check that. That's what I'm trying to find, is P final of the bus. That'll be the P initial of the bus minus the minus the P final of the vulcanized rubber man. Okay, so I'm going to flip. It looks like I'm going to flip the purple arrow here because I need said minus. So I'll come over here and flip this guy. Look at the length of it and just repeat it. 7. Okay, so I repeat it over here. Carefully. You need a ruler for this. You obviously can't do this with just shaky hands. All right, so let's see here. That was, we should double check that length. 6, all right, 6.7. All right, so that would be 10.7. So I'll redraw it. Change my color here. I'll do my ghosts in blue. So I'll redraw it. Oops. Right to there. Is that right? So redraw it right to there. That's the same as this purple just turned around. You triple check that because if this is wrong, everything's wrong. Yeah, that's about right. Okay, then the resultant goes from the very beginning to the very end. I'll go to the middle of the bus to here. Okay, so that's my resultant. This is, this right up here was negative P final VRM. So that's my answer, but then I've got to actually go up and draw it up here, so I've got to recreate this resultant here. So let me do some railroad tracks. I don't have a protractor with me, so I'll just do some railroad tracks. So I can try and get the, so I can try and, oops, sorry. So I can try to carefully get this the correct length and the right orientation. So I check my length here. And the length is, sorry, left-handers making this thing hard. All right, there we go. So the length is, okay, I see that. And gotta get the orientation right. It looks about right. So I'll do a different color now. This should be, I'll do it in red, I guess. this should be the, all right, that should be my answer. That is PB, P final of the bus. Well, that's good, except that I've got to describe it. So when I take my ruler and look at it, double checking everything. 35, 30, yeah, 400. Okay, if I check my ruler and measure it, and then multiply by the scale here, which is, where's the scale at? Use the ratios and the scales of the vectors to determine what direction. And the scale is somewhere on there. The scale, let's go with, when I use the scale, I'm going to get a length of, this equates to 500,000, about 500 kilogram dot meter per second. Okay, so that's the final momentum, but what they want to know is what's the speed, what's the mass, what's the speed. So this, I already know what the mass is. The mass of it was 22,000. So to find the speed, I just take that total momentum, that suitcase, and divide into it, or divide out the mass, and that gives me a speed of 22.8 meters per second. And this looks to be, I would need a protractor for this, but I've already done it earlier, so this looks to be about 78 degrees. So it looks like it is that mass, 22,000 kilograms, moving at 22.8 meters a second at 78 degrees north of east. And although that took a while, that's a lot faster than doing it component method.